A crucial pillar of sustainable production is design for disassembly and modular design more broadly, because in a sustainable world we want to reduce waste and pollution as much as possible and conserve resources where we can. Increased modularity also empowers more people to tinker and repair. A recent endeavour of mine is to homebrew a generator using 3D printed parts and some other accessories that can generate a usable amount of power. I tried to do the same with my so-called bean cannerator, and while I think it looked cool, the results of its performance were, to be frank, crap. Something I've been prototyping recently is these. These are what I call ModuCoils. Now, while a modular coil for a generator or motor or what have you might seem a bit unusual, there is some sense behind it. First off is its benefits for tinkerers. If you have these coils that you're using in a motor or generator or what have you, and you want to use them for another project without having to make another coil, then this would be ideal. Having coil windings be modular also makes sense in a more traditional setting such as a power station, because if there's a short, for example, you can just swap out the coil for another one, and that does happen because you see this copper wire here, it's only coated with a thin layer of enamel, and if that fails, you get a short. And so being able to swap that out means that modularity provides a lot of resiliency as well. Now let's talk a little bit about the construction of these themselves. This ModuCoil, this prototype, is wound with 100 turns of 0.4mm of copper wire. Also, you see I have these screws here connected to these nuts, and the purpose of these is to serve as a ferromagnetic material that will help magnetic fields penetrate through the copper wire better. Now, as I will explain later, I've made a little bit of a mistake with this prototype, which is why I have this one over there, which I will talk you through in a bit. But for now, enough blabbering on. Let's give this a test, shall we? What I have here is the rotor which I recovered from my bean cannerator. In the background I have my digital multimeter set to AC voltage, and here I have my prototype ModuCoil. So what I'm going to do now is give it a little bit of a test by spinning my rotor around with the coil in close proximity to it. If I spin it really fast, we can see we are getting to about, how high can I get this? Okay, so the highest I was able to get this was about 130 millivolts, which is a fast improvement from even my whole bean cannerator, but is still something that could be improved upon. Let's take a look at this coil a little more closely. When I was winding this, I wasn't taking into consideration too much how tight I was winding it. If I press down on the actual wire here, you can see it has a bit of give, it has a bit of a bounce, and that indicates that I haven't wound the wire around the coil holder that tightly, which impedes the amount of wire I can actually wind around here, and it also means that the wire as a whole is further away from the bolts, which help with the magnetic flux, obviously. Except these screws do no such thing. This is because they are stainless steel, or more specifically they are A2 stainless steel, and what that means is they are made of a material called austenite. Austenite is a specific type of iron created by a particular crystal structure that's formed when iron is alloyed with certain elements or is put under certain conditions. In this case, this is stainless steel, so it's iron alloyed with nickel and chromium and all sorts, and that makes these screws here non-ferromagnetic. This is my second ModuCoil prototype, and it has a couple of improvements over the first. Firstly, when I press down on here, there is very little bounce. I have wound the coil round its holder quite tightly. Secondly, instead of stainless steel, I have opted for carbon steel bolts. They are not austenitic, and they have a much higher iron content, and this makes them much more strongly ferromagnetic than the stainless steel screws I was using in the previous one. And we need a highly ferromagnetic material at the center of this coil because, as we know, we generate most electricity via passing a magnetic rotor across a coil of copper wire, and that's how we get most power. However, if we just had the wire and not the actual ferromagnetic core inside there, what would happen is the magnetic field from the rotor would not penetrate as much into the actual wire itself, and so less current would be induced. However, what's happening here is the magnetic field is passing on a little bit into the actual iron there, and that in turn is generating its own little magnetic field, which is inducing a little bit more current in the actual coil itself. Now, modern stator designs actually, they don't use screws or bolts or what have you. They use laminations of steel, and that provides a lot of efficiency. However, the problem is that with those laminations you end up with a monolithic stator rather than a modular one. However, these screws do serve a similar purpose. Let's test the second prototype. Same rotor, same size wire, same number of turns. Let's give it a go. Did I see 200 millivolts there? Maybe. I'll look back at the footage, but I definitely saw 180, and that is a little bit of an improvement over the other one. Now, obviously, it's not much of an improvement. These are still, quite small screws, and so the difference is not negligible. It is there, but it's not absolutely massive. However, those results weren't so reliable because it was just me spinning this incomplete rotor with my hand and it moving about all over the place. However, when I get these ModuCoils into a generator, I hope to record some actual scientific results. I'm still to improve these ModuCoils even further. A simple improvement I could make to this is to actually use a different size wire. If I was to opt for a smaller size wire, such as a 0.2mm instead of 0.4mm, that would mean I could wind more turns. More turns equals more voltage, etc. And so I would get a little bit more power output from that. In fact, quite a lot, I think. Yes. Let me know what you think of this ModuCoil idea. I'll upload the STLs for these coil holders, and yeah, stay tuned for when I put these into a generator and see what happens. Take care, stay safe, stay inquisitive, and bye for now.